In this video, we will practice rewriting logarithmic expressions using the properties of logarithms. This is AP Precalculus topic 2.12. If you appreciate this content, please give it a like. These are the 4 log rules that you need to memorize. Pause the screen and take notes if you need to. For each of the following, write an equivalent expression using a single logarithm. For number 1, we can use the product rule, which tells us that we can write a sum of logarithms as a single logarithm involving multiplication. So this will be the log base 6 of xy. We can solve number 2 using the quotient rule, which tells us that we can take the difference of 2 logarithms and rewrite it as a single logarithm of a quotient. It'll be the first one divided by the second one. So z over 4. Quick side lesson. If you have multiple log terms involving addition and subtraction, you can rewrite these as a single log in one step. It will be the log of a quotient, and because we have 4 terms, there will be 4 factors in the quotient. You just have to keep track of which terms will end up in the numerator and which factors will end up in the denominator. Any factor that comes from a negative term will end up in the denominator. So the a will go in the denominator because this is a negative term. The b will end up in the numerator because it comes from a positive term. The c will end up in the denominator, negative term, and the d will end up in the numerator. It came from a positive term. So for number 3, we should easily be able to rewrite this expression as a single log in one step. The log 5 is a positive term, so we will have a 5 in the numerator. Because the middle term is negative, we will have a 2 in the denominator. The last term is positive, so this x will belong in the numerator. This purple power rule tells us that if we have a number multiplying in the front, we can move it to the exponent. We have to do this before we can do the product rule or the quotient rule. On number 4, we have to move this 3 in the front to the exponent before we condense the rest. So we will have the natural log of x minus the natural log of y to the 3rd power minus the natural log of z. Now we can write a single log of a quotient, and because the first term is positive, we will put the x in the numerator. Middle term negative, so the y to the 3rd power belongs in the denominator. The 3rd term is negative, so we will have a z in the denominator as well. So that's it for number 4. On number 5, we need to move this 1/2 to the exponent, and we need to move the 4 to the exponent. So we will get the log base 3 of x plus the log base 3 of y to the 1/2 power. Understand that y to the 1/2 power is the square root of y. So I'm going to prefer to write it that way. Square root of y minus the log base 3 of z to the 4th power. Now we can write a single log. The log base 3 of a quotient. The first term was positive, so the x goes in the numerator. Middle term positive, so square root of y in the numerator. 3rd term negative, so z to the 4th power goes in the denominator. To begin number 6, we need to move the 2 to the exponent and the 3 to the exponent. So we will have the log of 4 squared, but 4 squared is just 16, so let's go ahead and just put that. Minus the log of x to the 3rd power, and then minus the log of 5. Now we can write a single log of a quotient. The first term is positive, so the 16 goes in the numerator. The middle term is negative, so we will have x to the third power in the denominator. The third term is also negative, so the 5 will go in the denominator. For number 7, we will first move the 1/2 to the exponent. We will make the 2 the power of 3, and the 4 will become the power of w. Remember that the 1/2 power is the same thing as the square root. So I'm going to write log of 3, because 9 to the 1/2 power is the square root of 9, which is 3. And then I will have 3 squared, that's 9, I'm just going to put a 9. And then minus log of w to the 4th power. Now we can write a single log of a quotient. The first term is positive, so I put a 3 in the numerator. The second term is also positive, so I need to put the 9 in the numerator. It is multiplying. And the third term is negative, so w to the 4th power belongs in the denominator. But let's go ahead and multiply 3 times 9 and get 27. Number 8, moving 2 to the exponent gives us the natural log of x squared. Moving 3 to the exponent, we have natural log of y to the 3rd power, and then plus natural log of 8. We can immediately write this as a single log expression. There are no minuses, so this will not be a quotient. This is all multiplication. It will be the natural log of x squared times y to the 3rd power times 8. But I'm going to put the 8 in the front. Number 9, let's bring down the log base 7 of 3 and the log base 7 of 4. But before we do anything else, we need to make the 1/3 in the front become the exponent. So I will have minus log base 7 of x to the 1/3 power. I could replace this with the cube root of x if I wanted to. I think I will leave this as x to the 1/3 power just because I can. Now we can rewrite these as a single log. So this will be log base 7. The 3 will go in the numerator because this is a positive term. The 4 will go in the denominator because this is a negative term. And x to the 1/3 power will go in the denominator because it comes from a negative term. So that's it for number 9. Number 10. Which of the following expressions is equivalent to the log base 3 of 4x squared over w to the 5th power, where x and w are positive constants? I see 3 factors inside this quotient, so we can split this single log into 3 separate logs. So we can write the log base 3 of 4. This will be positive because it comes from the numerator. And then we will have plus log base 3 of x squared, positive because it comes from the numerator, and then minus log base 3 of w to the 5th power. This one is negative because this factor came from the denominator. Now we can take any exponents and move them to the front of their respective terms. So in the end we get the log base 3 of 4 plus 2 times the log base 3 of x minus 5 times the log base 3 of w. Looking at the options, the answer is C. For number 11, I see 4 factors inside this quotient. So I'm going to split this up into 4 terms. So we have the natural log of 4 plus the natural log of y. These two terms are positive because these factors came from the numerator. But then we have minus natural log e to the third power minus natural log square root of x. These two terms are negative because these factors came from the denominator. I don't want to rewrite the whole thing just for this one change, but the square root of x is the same thing as x to the 1/2 power. So I'm going to make that change. Next, we can use the power rule to move exponents to the front of their respective terms. So we have natural log 4 plus natural log y minus 3 natural log e minus 1/2 natural log x. The natural log of e is 1 because natural log really means log base e, so natural log e is log base e of e, and e to the 1 power is e. So this is 1. So that means when I look at the answer choices, I will not see it show up. Okay, it's just going to be a 3. So looking back, we see that the answer is C. Number 12. Which of the following is equivalent to this expression? Let's move all of these coefficients in the front to the exponent of each term. So this will become the log of x to the 1/2 power minus the log of y to the third power minus the log of 3 to the second power. X to the 1/2 power is the same thing as the square root of x. So we have that, and then I'm just going to bring down minus log y to the third power. And of course, 3 squared is 9. So this is minus log 9. We can combine all three of these terms into a single log by writing each factor either in the numerator or the denominator based on whether the term was positive or negative. So this first term is positive, so the square root of x will go in the numerator. The other two terms are negative, so the y to the third power will go in the denominator, and so will the 9. So looking at the answer choices, the answer is D. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.